So here's an example. We've chosen Bill, Wyoming, or the origin, to be right here. And there are three pieces. There's this circular arc. We should give it names. Let's call that Squanch. There's this line here. Let's call it Walrus. And there's this line here. Let's call that line Squirrel. Don't do this in the homework, please. I'm just trying to use your words. So we're going to make a table, and actually the names help me a lot. This is Squatch, the circle. This is Walrus. And this one is the line we called Squirrel. We need the length of each of these. So Squatch is a half circle, so pi times the radius. Walrus was 40 millimeters long, and Squirrel was that vertical one, which was 20 millimeters long. We need to find the X bar, Y bar, and Z bar for all three of these pieces. So finding the center of gravity of the Squatch, that half circle, might be a little hard. We know the X centroid is right in the middle of the circle, and that's 60 millimeters from Bill. However, the Y coordinate, where is this centroid of this half circle? That's a little hard to do. We're actually going to have to do a separate problem and do that integral to get that Y centroid. Or if you look in the back cover of the book, if you have it, there's a table, and it'll show a half circle in there. It won't say that its name is Squanch, but it will look like a half circle, and it will give you a formula for the Y coordinate. And if you plug it in, you'll get 38.2 millimeters from the center of the circle to the centroid of a half circle wire. And it's negative because of the way we've picked Bill, Wyoming. It's to the negative Y direction of the coordinate system. And what I'll do for the final is I will give you a photocopy of the inside back cover of the book so you don't have to do this. So if it's any normal shape like half a circle, quarter of a circle, or something like that, you'll have the centroids all ready to go. And continuing on, the Z centroid of Squatch is 0 because it was in the XY plane. Next, we move to Walrus, which was that horizontal 40 millimeter line in the Y direction. Its X centroid is 0 because it's right at the origin that goes through Bill, Wyoming. Its Y centroid is half of the 40, 20, and it also has a 0 Z centroid because it's in the XY plane. And finally, we look at the line that we called Squirrel. That's the 20 millimeter line that's vertical. It has an X coordinate of 0 because it's just right there on X equals 0 if you look in the picture. It has a Y centroid of 40. If you look at it, the entire line is 40 millimeters from Bill in the Y direction. And finally, it has a Z centroid of minus 10 millimeters to the middle of Squirrel. It's 20 millimeters long going down in the Z, so halfway down is minus 10. And this is where Excel comes in handy. You type in this cell, X bar times L, and you put the dollar signs on the column for L. And then you just copy it over, and you'll get Y bar times L, Z bar times L. And then you copy down in Excel, and these will all fill out. And then you just need to add up everything, and then again in Excel, there's a sum function. You just press it once, and you'll get all those things. And then we're ready to calculate the centroids. I mean the centroid, the X, Y, and Z coordinates of the centroid. The X bar is just sum XL over sum L, 45.5 millimeters, sum YL over sum L, minus 22.5, and sum ZL over sum L, minus 0.805 millimeters. This centroid is all relative to Bill, Wyoming, which is the origin of the coordinate system.